Hi, Stephanie. Sorry not to reply yesterday. I was working on it and then I had to go out last night and do an extracurricular with the school that I teach at. We're getting ready for the Santa Claus parade. So here is what I came up with for the problem that you sent me. There's two ways to do it. I've set it up here with 7 minus x and x for the length of the shore. If you did it the other way around, you could put an x there and a 7 minus x there, and I think it doesn't really make much difference in terms of the equation that you end up with and how complicated that becomes, because it's a little bit tricky. So what I did first is I know that what we want to do for the length of the cable is include the diagonal and a straight stretch, and that we're trying to do a cost minimization, so we'll get to the cost function in a minute. But what I did first is I assigned the shoreline distance as x, and I called this one c for the hypotenuse of the right angle triangle, and I used Pythagorean theorem to solve for c in terms of x. Then what I did was I took the length of the cable to be x plus c, so x plus c, and I substituted c, what I had just found from the Pythagorean theorem, in there, and that gave me the formula for length of the cable. But now it gets more tricky because it's a cost function and there's different costs associated with the different directions of the cable. So it's cheaper to go along shore. It's 400 for every x along the shore, and it's 500 for every foot or whatever, meters, I don't know, I can't remember what it said. Anyways, along the diagonal. And so if you make your cost function with the 400 times the straight stretch and the 500 times the diagonal, then that's what we end up with. And that is equal to that, okay? So now it's time to take the derivative and try to minimize the cost by setting the derivative equal to 0. So here's what I did. I'm going to just move this up. Okay, here we are. Taking the derivative, if I did things correctly, that's what you get. And this is 2x minus 14, okay? That's from the chain rule. This is the chain rule from this. And so simplifying that, the negative 1/2 exponent, that puts that part of the answer down in the denominator for now. And I multiplied 250 times 2x minus 14 to get the top here. And then I set the thing equal to 0, the derivative, okay? So I've got the steps shown there, and you can go through those step by step if you like to work through the equation. I'll just explain what I did here in case this isn't clear. I squared both sides of the equation here. So from this equation here down to here, that's why I got rid of the square root, because I squared 400 and got 160,000. I think that's right. I didn't use my calculator on that one, so you might want to just double check my numbers. You know what, I'm just going to double check that right now. 400 squared is 160,000. Okay, it's early in the morning. So we have 160,000, and then the square root bracket will just become without the square root when we square it. And then I had moved the other two terms over to the other side, and I see a bit of an error there because when I moved them over to the other side, I should have changed the signs on those guys. That should have been a negative, and that should have been a positive. I wonder why I did that. Sorry about that. Let's see if we can fix this up as we go along then. So, all right, it won't make any difference to this number because when I square it, it's still going to be positive. It won't make any difference to the second number because negative times a negative is still a positive, so that one's going to be okay. and it won't make any difference here. So it still works out correctly even though I messed up the signs there, okay? So what I did there is I FOILed the binomial. I multiplied the binomial by itself, and that's how I got these three terms on the right, and I had to go down to the next line because I ran out of space on my page there, but that should all be on one line. So the next part of it is just simplifying and putting things all together on one side. This here, again, I ran out of space, and it just says equals 0 on the right-hand side. And so if you end up with the function that I ended up with, and you divide everything by 10,000, you get 9x squared plus 49 minus 135 equals 0. It's not factorable, so you could use the quadratic formula. What I did is I went to Symbol Lab and I just typed it in and it solved it for me. The two roots that you get are 3.1 or negative 3.1, which of course can't work in this case because it's a negative length. And so that would make the straight stretch along the shore equal to 3.1. And then over here, I just did the math on the 7 minus that and got 3.9 for the other side of the triangle. Or not the other side of the triangle, for the other length of the shore for the remainder. And what I didn't calculate was C. I don't think it asks you to. I think it just asks you where the cable needs to turn and start going diagonally. But if you wanted to go back and find C, we definitely could do that because we defined C way back here. And we could just substitute 3.1 in for x into that formula to find the value of C, which is the length that it would go along this diagonal. So I hope I got it right, and I hope that helps. And I'll keep checking my email throughout the weekend because I think you said your assignment was due on Monday, and if you have any further questions, then just send them my way.